Hello friends, welcome to Math Opera. Myself Salil Gadgil. In this video, I am going to show you how to construct some special angles like 30 degree, 45 degree, 60 degree, 75 degree, 90 degree, as well as 120 degree, 135 degree, 150 degree. Not just that, I am also going to explain the geometry behind this construction. Let's get started. So in this segment, I am going to explain the geometry behind construction of a 60 degree and a 120 degree angle. I have marked a line over here. I have marked a particular point A. I am going to construct 60 degree and 120 degree around it. I suggest you take out your geometry box, your geometry instruments, and construct this along with me. So what I am going to do is, I am going to take any suitable measurement on my rounder. I am going to place this particular point on vertex A. I am going to fix it there, and using any measurement, I am first going to draw a semicircle. I hope you are also drawing the semicircle along with me. So the semicircle is intersecting the line segment at 2 points. Using the same measurement, without changing the measurement, I am going to place the rounder on one of these points, and I am going to draw an arc with the same measurement without changing the measurement. So when I mark an arc over here, I will mark an arc over here. Again, without changing any measurement, place the rounder on this particular point and again draw an arc which intersects the semicircle. So these two markings will give you 60 degree and 120 degree. Let us find out how. So what is the first thing that we did? We took a particular rounder measurement and we drew a semicircle. So let's name these 2 points as x and y. The measurement of ax and ay is going to be exactly equal. So I have marked these two line segments as equal because the rounder measurement was exactly the same. With the same rounder measurement, you cut out two arcs, say let's call them M and N, okay. So since you took the same measurement on the rounder, and if I join these particular 2 points, say MY as well as AM, what is it that you notice? The measurement of MY is exactly the same as measurement AY because you did not change the rounder measurement, which means these two segments are also equal. And since this is a semicircle, AM is equal to AY, A being the center of that semicircle. So what type of triangle do you observe over here? This is an equilateral triangle. We know that every angle in an equilateral triangle measures 60 degree, and therefore this angle turns out to be a 60 degree. So if you want a 60 degree angle, this is how you can construct it. And what is the geometry behind it? You are actually constructing an equilateral triangle there. Then what did we do? From the point M, with the same rounder measurement, we did not change the rounder measurement, we drew the point, we marked the point N. So if I join M and N and A and N, again over here the measurements remain exactly the same as the radius of the semicircle. So all these three measurements are also equal. Again, triangle ANM is also an equilateral triangle because all the three sides are equal. So again the angle over here is also 60 degrees. So how much is the total angle? Angle YAN, the complete angle is 60 degrees plus 60 degrees. So you get 120 degrees over here. So what we are doing in construction of 60 degree and 120 degrees, we are basically constructing equilateral triangles. This is the geometry behind the construction of 60 degree and 120 degrees. In the next segment, let's take 30 degrees and 150 degrees. So in this segment, I am going to show you how to construct 30 degree and 150 degree. I have already drawn the 60 degree and 120 degree angles, which I showed you how to do it in the previous segment. So in this segment, let's see how 30 and 150 can be drawn. To draw 30, I need to bisect 60 degrees. So over here, angle BAE is equal to 60 degrees. So I'll mark this particular angle as 60 degrees. I need to bisect this particular angle. So let's see the geometry behind bisection of an angle. With the same rounder measurement, so I have already drawn the semicircle with a particular measurement. I am keeping the same rounder measurement. I am placing the protractor, I am placing the rounder on B. I am drawing an arc. Okay, I hope you are also doing this in your notebook along with me. I am again keeping my rounder on the point E, and with the same measurement I am drawing an arc. It is important to keep the same measurement when you draw these two arcs, and you should keep the same measurements for the following reason. Now if I join point A with this particular point, let's call this point as say M. If I join the point A with point M using a scale, that should give me a 30 degree angle. So if you actually join these 2 points, you will get a 30 degree angle. You can also measure it with your protractor and you will notice that you get a 30 degree angle. So now let's see what is the reason why we get this 30 degree angle. So the idea here is, what we did was, the rounder measurement was the same when we drew AB and AE, correct? This is the radius of that semicircle. With the same measurement, we kept the rounder at point B and we drew an arc, which means that BM is equal to the radius of the semicircle, because I did not change my rounder measurement, which tells me that AB is equal to BM. If you notice, I drew this particular arc from the point B. So every point on this particular arc that I drew is equidistant from the point B, that is equal to the radius of the semicircle. So M is equidistant from B, as well as A and M are both equidistant from B. The distances are same. If I join E and M, again I kept my rounder measurement exactly the same. So the distance EM is also equal to the radius of the semicircle. So what you notice now, look at the quadrilateral ABME. In ABME, you will notice that all the 4 sides of the quadrilateral are equal, and therefore it qualifies it as a rhombus. If 4 sides of a quadrilateral are equal, it is a rhombus. There is a special property in a rhombus that the diagonals of the rhombus bisect the vertex angle, and that can be proven using congruency as well. How can you prove it? If you consider these 2 triangles, triangle AEM and triangle ABM. So triangle AEM and triangle ABM are congruent to each other if you take the side test for congruency. So since these 2 triangles are congruent to each other, the corresponding parts are equal, applying CP/CTC. So these 2 angles are equal, and therefore the 60 degree gets bisected as 30 and 30. And that's why you get a 30 degree angle there. Similarly, this whole angle is 60 degree. So angle DAC is also 60 degrees. If you bisect this particular angle, so I am just drawing it with a rough hand now. If you bisect this particular angle, then you are bound to get this particular angle as 30 degrees. The one that I am shading on the board. This angle is 30 degree. Angle DAB is 120 degree. So this total angle is 120 degree. This 120 degree with this 30 degree will give you a 150 degree. The other way of looking at it is angle, so let's name this particular point as N. So NAC, this particular angle is 30 degree, and therefore the remaining part of the angle, this complete angle, is bound to be 150 degree. So this is the geometry behind 30 degree and 150 degree. In the next segment, I'll show you how to construct 90 degree, 45 degree and 135 degree. So in this segment, I'm going to show you how to construct 90, 45 and 135. I have already marked the semicircle with the 60 degree, 120 degree markings as we saw in the earlier videos or in the earlier segments. Now over here what we are going to do is, we know that angle XAM is 60 degrees. So this particular angle is 60 degrees. and there is a 60-degree angle over here as well. What we are going to do is, we are going to bisect this particular 60 degree so that we get a 30 degree out of it. That 30 degree, the bisected 30 degree along with this 60 degree will give us a right angle. So how should we bisect this particular angle? Angle MAN. We keep the rounder over here. We take a suitable measurement. We construct an arc with the same rounder measurement. Keep the rounder on N and construct an arc. So what we have essentially done is, over here we have actually changed the rounder measurement. So initially we know that the rounder measurement for the semicircle ensures that AM is equal to AN. Now over here, since I was short in space, what I did was I reduced the rounder measurement, and from M and N I took the same rounder measurement and I constructed two arcs. The point where this particular arc intersects, we join that particular point with the point A. So let's see how changing this particular measurement also gives you an angle bisector. Essentially what we are doing over here is, AM is equal to AN because it is the radius of the semicircle. If I join points N with, say, let's name this particular point as P. If I join N with P and M also with P, since the rounder measurements were exactly the same, these two sides are equal. That is, Pn is equal to Pm. These two measurements are exactly the same. So what figure is ANPM? It is a quadrilateral for sure, but it is also a kite. It is a special quadrilateral where the two adjacent sides are equal. So PM is equal to Pn and AN is equal to AM. So this is a kite. There is a special property in kite where we know that the longer diagonal, so if you join the point A with P, it is going to bisect this angle A. This is the property in a kite. So if I join P and A, now this 60 degree gets bisected as 30 degree and 30 degree. So this 30 degree, this angle which is 30 degree, the angle which I have marked over here is 30 degree. Along with this 60 degrees, this total angle makes up a 90 degree. So you get a right angle over here. This particular angle, angle XAP, is a right angle. If you have constructed this, you can take out your protractor and you can actually measure that angle and you should get a 90 degree over there. So once we have constructed 90 degree, how can we get a 45 degree? It's simple. We just bisect the 90 degree and you should get a 45 degree. So how can we bisect the 90 degree? Let's take a suitable measurement. So I am going to take the radius of the semicircle itself. So we take the radius of the semicircle, or you can take any other measurement that you want. Okay, let me take a different measurement. First draw two arcs. One arc should intersect AP and the other arc should intersect AX. From here, from the point where it intersected, with the same measurement draw an arc, and from this particular point draw arc with the same rounder measurement. So in essence you are actually drawing a square over here, and we know that the diagonal of the square, if you join this particular point with the point A, the point where the two arcs meet, if you join that particular point with A, so let's name this particular point as D. If you join A and D, you will get a 45 degree angle. It is simply because you have bisected the 90 degree angle. Now how can you get a 135 degree measurement? You already have a 90 degree here. Angle XAP is a 90 degree. You want to additionally add 45 degree to it to get a 135. So we know that angle PAY is also 90 degree. If we bisect this right angle, so this is a right angle. If we bisect this particular right angle, you will get a 45 degree out of it. So this particular angle will be 45 degree. Let's name this particular point, say, as E. So we know that angle YAE is equal to 45 degree, and that makes angle XAE, so this implies angle XAE is going to be 180 degree minus 45 degree, and that equals 135 degree. Why is that so? That's so because YAX is a straight line and the complete angle around the straight line is 180 degree. So from a 90-degree angle, we were able to construct a 45-degree angle, as well as we were able to construct a 135-degree angle as well. So now in the next segment, I'll show you how to draw a 15-degree angle as well as a 75-degree angle. So in this segment, I'm going to explain how to construct 75-degree and 15-degree. I have already drawn the conventional semicircle with 60 degrees shown, 120 degrees shown and 90 degrees shown as well. So we know that angle XAD is equal to 60 degrees. This is how we constructed the 60-degree angle. Now if you bisect angle XAD, we saw that we get a 30-degree angle. So angle PAX is 30 degrees. So this particular angle is 30 degrees. Now if you bisect this particular angle, you are going to get a 15 degree. So if you bisect angle PAX, keep your rounders on X and P with the same measurement cutout arcs, and you should get the arc somewhere over here. Join it with the vertex A and you will get a 15-degree angle. So this is how you can construct a 15-degree angle. On top of it, actually, if you bisect 15 degrees, you can even go down to 7.5 degrees. So now let's see how to construct a 75-degree angle. We know that angle XAE is 90 degrees. So this complete angle over here, the complete angle is a right angle. Let me just erase what we just wrote for 15 degrees so that it gets even clear. So we know that this complete angle, angle XAE, the complete angle is a right angle. If you bisect this, and we know that angle XAD is equal to 60 degrees. So angle XAD is 60 degrees. This was the part of the equilateral triangle that we saw. So angle DAE, this particular angle is 30 degrees. If you bisect this 30 degrees, then you are going to get a 15-degree angle. So from A, you already have these 2 points. Take the same measurements on your rounder from this point as well as this point and construct arcs over here. So when you join point A with this particular point, you will get a 15-degree angle. So this particular angle that you have here, this angle is 15 degrees. And this complete angle is 60-degree angle. So if you add these two angles, 15 degrees along with 16 degrees, you will get the 75 degrees. So angle XAQ, if I label this particular point as Q, then angle XAQ is going to be 60 plus 15, that is 75 degrees. So we saw that in construction of all these angles, we are basically using a few properties. One property was the property of equilateral triangles. The other property that we were trying to use was that we were trying to construct either a rhombus or a kite to get an angle bisector. And using angle bisectors and equilateral triangles, we were able to construct all these special angles. I hope that you understood how to construct all these angles and that you constructed them with me, and I hope that you enjoyed constructing it. There is a lot of geometry behind all these constructions. Once you understand that geometry, you begin to appreciate constructions. I hope that you found this video useful and interesting, and that geometry makes much more sense to you now. In the next video, I'll come up with some new idea, some new concept. Do like, share and subscribe my YouTube channel and stay connected for more updates. Let's learn mathematics, let's understand mathematics and enjoy it. Goodbye.